Okay, so now I'm at the lecture 13, I think. It's module 3. If you are watching this lecture, I have recorded approximately 10 to 12 lectures before this course, which cover all these projects. Explanations of all the work that is performed on ABAQUS. It has 2 labs that are covered in this lecture. So today's lecture is based on the single layer system in flexible pavements, and it's a practical project um, which have a lot of information that are included in this project. And if you have purchased this course, you will find out these codes in the folder here. This is the folder which is the name of project 1, inside which all these parameters are present. So overall, before proceeding, I am trying to show that um, what are the results of this project. So these are the results of the project. This one is for the unloading, when the road is unloaded. So we have cycle number, which is cumulative operating depth, and we have this deformation or rating depth when the cycle is active on the model. So along with it, there are a lot of discussions on this model. So also we have some writing animations here, which are I think too lengthy to show here. But anyhow, let me show you that how this rating depth is evaluated here. Also, we have this file that is shown here, and I don't know if we can increase the speed. But anyhow, you can see here that these loads are applying here in terms of repetitions, and we are getting the results. So this lecture cover the overall contents of this project, and it's a practical project that is demonstrated inside the ABAQUS. So it's a single layer system in flexible pavements, and we need formulation for it in terms of creep, which is included here, and I'm going to explain that one by one, just like it's given here, right? So we need rate dependent plasticity, that is creep and swelling, and the link is given here. So you can just visit to the link if you kind of in search of further details about this model, and this link will launch the page from which I have considered the material idealization. So you can see here, as soon as I clicked on the link, all the information are loaded here. The internet is slow. Anyhow, you'll be able to understand how this project is considered here. So for the rate dependent data, we are using creep model, and we have the input file usage. So for the input file usage, you can write the material name and then define the creep parameters accordingly. And if you are using the mechanical properties in the ABAQUS CAE usage, then I'm also going to show you that. Before that, let me open the road profile for the full scale. This is a general model and this is a full scale model. So for the full scale model, let me open the model here. And a power law model is considered here, which is covered in this discussion. And these are the creep and epsilon, temperature, and N models, and elastic consideration is provided in this model. So the thing is, all these details are given here, even if you have the creep versus the strain, time versus strain for the creep data, and creep with relaxation data for the respective pressure, then you can use that in your ABAQUS model. So let's look into the project, and here in this project we have this single layer system for the flexible pavement. So most of the time in a single layer system for flexible pavement, the focus is on the simplification of the modeling approach to actually capture the material response, and it's basically very important in lab-based simulation, and when the tests are conducted in ABAQUS based on the lab data. So the definition of the single filament with adequate material properties and consistent thickness, it's very important for realistic outcomes. And if I show you, I have done this model. It's a full-scale quarter model, and the load that is considered in this model is in such a way that each repetition represents every tire passed in this model. So we don't have any other material here, any other part. This is a single part that is considered on the edge. We have symmetrical boundary conditions, and we have this creep model. Properties are assigned to it based on the creep data, and these properties that are used in this model, these actually give you the actual behavior of the asphalt based on the creep parameters here. So those creep parameters, those are already, as I mentioned, those creep parameters are present here. So just in case, if you want to define the properties, I'm going to explain the properties in the next video in detail. This is just an overview of the model. Then we have the assembly of the model, and if I switch on the mesh view, you can see here that we have a very good mesh. And after that, if we go to stiff, so for the stiff, I have this repetitive loading step. Now it's important that for the repetitive loading step, we need to define either Visco model or any other model in our consideration for the modeling environment. And here I have this whole model: creep, equilibrium, plastic strain, parameters, and all those steps here. So other than that, I don't have any hasty output request in this model, and similarly, I don't have any interaction in this model. For this, for loading consideration, it's important to know that the load should be applied in terms of each single passing tire impression here, right? For example, if I have this load here, look at here this model. I will explain this because I have this Python code from which I generated this load. This is for the speed for the wheel starting and ending point, and this code actually generates the distance between the starting and ending location, and then work on the consideration of the cyclic repetition. So these are for the repetitive cycles, and these are for the repetitive cycle full-scale models. So there was a difference between the repetitive cycle and full-scale repetitive cycle model. I'm going to show you this code just in case if you want to pause it and look at the code to see what is inside the code and what are included inside the code, right? So I will go to show line number, and then you can look at the code here, right? So it's generating workbook for us, which I'm going to explain here. It's going to assign the tire label. It's going to assign proper labels in this code here. So this is one code that's used for the relative positioning, right? And even if I show you, we have this tire 1, tire 2, tire 3, and various locations which are controlled by Python here, right? So after that, we have mesh, right? And after mesh, then we have the job. So for the job, the data check is completed here, while the job is submitted with Python.